evening, and welcome to Shop Talk, hosted by the Triangle Area SQL Server Users Group. So Shop Talk, if this is your first time around, welcome. This is an opportunity to spend some time on a Monday after work and kick back, enjoy some conversation, a little bit of chat-driven discussion, a little bit of hanging around. Howdy, Anders. Good to see you. Hey, Rednello. Good to see you as well. Unfortunately, tonight, it's just me in here. Mala had a company meeting. Mike's dealing with some personal issues. Everything's fine there. And Tracy is currently kidnapping world leaders in an attempt to earn millions of dollars. So I probably shouldn't have said the last one out loud. That was supposed to be a secret. But this was how we were going to finance TriPass for the next few years. Anyhow, tonight, just me. Got a few topics. I've got my board over this way, which if you've never been to shoptalk.tripass.org, this is actually where we have all of the show notes for every episode. So you can check it out if you want old videos. Incidentally, I always look terrible in the clip because I tend not to find good photos during the episode. So if you want to see what goofy face YouTube has chosen for me in any particular week, it's all right there, shoptalk.tripass.org. Got to finance her SQL superhero activities somehow. Yeah, I think after this one, she'll end up being a SQL supervillain, but we haven't gotten that far yet. In a balloon over Montana. Oh, I hope not. I hope not. So a couple of quick notes. Quick note number one, SQL Saturday Raleigh update. So we've been working trying to get a venue for SQL Saturday Raleigh. Hasn't come through at this point, and given that we were trying to do it in sometime in mid-April, mid-April is not going to work out very well because of Microsoft MVP Summit. We tried to move it back to late March. Late March venues aren't available that we were looking at, and we're getting close to a point now where we're probably not going to be able to do a SQL Saturday, at least in spring. There is a possibility of doing something in the fall. Probably would avoid trying to do something in summer, but we'll leave some doors open in case we put together something that's a little bit smaller. But just so that this is why we haven't, for example, put anything on the SQL Saturday website. Right now, the likelihood of it going live, pretty low. That might change, but probably not unless we hear some good news very soon. The Triangle SQL Christmas Spectacular. I mean, as long as it doesn't snow, typically we'll have, 60-something degrees in late December. And if you hit it at just the right point where it's that 60-some degree day, yeah, that would actually be a really good day. But if you hit it when there's that 19th of an inch of sleet, nah, hard pass. Nobody would show up. I'd have to go back and dig up the picture of Glenwood Avenue with cars on fire and everything. So, plus, even if we did it, there'd be 4 people who showed up, and I'd be one of them. Nonetheless, we'll try to get something sorted out. I know that there were a fair number of people interested in a SQL Saturday, and I would like to get something. But unfortunately, venues have been really difficult for us to get so far. So that's been the big issue. Next thing that I wanted to talk about, a little bit of tech layoff news. We've seen over the past couple of months a lot of companies laying off. Microsoft, Google, Facebook, Amazon, tens of thousands of people. I've seen other major companies laying off like 10, 20, 30% of their workforce, and hopefully people aren't getting affected by that too much here. One thing that I will point out, this was something that Andy Leonard mentioned and I brought up on last episode of Shop Talk, but it is still valid, it is still around, and that is the generous offer for anybody who has recently been laid off, where if you have, you can get his Enterprise Data and Analytics Premium level for 1 year. And it's a full year of recorded trainings for free. Give you an opportunity to learn a bit about Azure Data Factory, or if you're not familiar with SQL Server integration services, there's still a lot of companies that are using that on premises, and learn from a man who's written several books on the topic. So that's a great option. Highly recommend if you are in that scenario where you have been laid off. Take advantage of it. Speaking of layoffs, unfortunately, I have just been laid off, so that's okay. So company's doing a little bit of cutting. Not a big deal for me. Don't cry for me, Argentina. I've decided, all right, I'm going to take a sabbatical. I've been meaning to do something like this for a little while. I just like getting paid, but getting a severance, and I'm going to take some of that time, take a little bit of time, and go back, retool, retrain, read some books that have been piling up, write some content, put together a couple more talks, stuff along those lines, and then I'm going hard into consulting. So over the past few years, I've been straddling this line where full-time job, managing people, and also doing consulting nights and weekends. I'll finally have time to get rich. Exactly. I won't have the money to get rich, but I'll have the time. And time is money, according to most formulas. So time also compounds, I guess. But I'll be going hard into consulting, hard into content creation, spending more time on that stuff. So on the whole, we'll see. We'll see. I did spend 9+ years at this company, so a lot longer than I expected to be. I normally get the itch to leave after about 3 to 5 years, and I stuck around for, one 3 to 5 year segment, and then transitioned to a different role in the company and stuck around for another 5-year segment. Do I have an area of specialty? Yeah, the answer is yes. And the area of specialty is yes. Technically, I ran a predictive analytics team, or will run it until Thursday. So Thursday's that final day. Our entire team is getting laid off. It's unfortunate, but some really smart people, and they will land on their feet, I know. But predictive analytics, database development, database administration, data engineering, data science. Short answer is yeah, a lot of this stuff. Application development, yelling at people. I'm pretty good at yelling at people. Although I used to be a lot better at yelling at people. I've gotten soft in my old age. But yeah, like I said, I'm actively not looking for work. Going to take a little bit of time off and then do consulting. And in that area, that specialization within consulting, it is broad-based. Pretty much anything relating to data, and especially the SQL or Azure world. That's kind of where I live. And so there may be some more info. I'm not going to use Shop Talk as a platform to try to drive people toward consulting with me. But I figured, you know what? This is a big thing. Came down today, so I'll talk about it. Especially with nobody else on here to counterbalance my monopoly of time. So it's unfortunate, but there's a lot of companies that are in the midst of layoffs. Hopefully everybody else is doing okay, and that if you're looking, hang on and keep looking, and hopefully you get something good. In the meantime, there's a lot of free content. I recommend taking advantage of it. Like I said, Andy's offer is very generous, and he's got some great content to go through. So take that opportunity, build up some skills, and get back in it if you can. The next thing that I wanted to talk about, so this is story number 1 of the night, and that is why Eugene is struggling with learning Azure Synapse Analytics. So this is doubly apropos because For the SQL Data Partners podcast, we just recorded it in an episode today with Eugene Meidinger. If you don't know who he is, he's one of my co-hosts. We are the backup singers for Carlos El Chacon of the SQL Data Partners podcast. That is SQLDataPartners.com/podcast. If you've never heard it before, we basically riff on stuff. It's not quite like this. It tends to be a little bit more structured and formulaic than what we do here, where, I mean, it's just, Mala, Tracy, and Mike trying to rein me in. But for the podcast, there's quite a few episodes we've done together. And one that's coming up very soon will involve Azure Synapse Analytics. And the premise of it comes from this blog post by Eugene. So Eugene is somebody who has specialized in Power BI. He spent a lot of time on the topic. He's spent a fair amount of time developing content for Pluralsight, learning about DAX, understanding how the Power BI ecosystem works. And he has a nice metaphor for Power BI as 3 raccoons in a trench coat, Power Query, DAX, and visuals, meaning these are really 3 different products, 3 different offerings that are smashed together in a way that they fit in one broader rubric, but knowing Power Query doesn't necessarily help you know DAX. Knowing how to lay out visuals doesn't necessarily help you build up Power Query M code or DAX code. So there are several separate, roughly independent skill sets, and I guess you learn to build on this in order to get to the end product, which is your workspace, your applications built out of Power BI. Well, as Eugene is learning about Azure Synapse Analytics, he's realized that, Synapse is like 10 of these raccoons that are all connected together, and very difficult to fit it together very nicely. Because when you think about it, Azure Synapse Analytics, you have that data lake Gen 2. So your data lake forms the basis, that storage account. On top of that storage account, you may have a dedicated SQL pool. You may have a serverless SQL pool. You may have Data Explorer pools, Spark pools. You'll also have the Synapse pipelines. So effectively Azure Data Factory for Synapse. You've got 1, 2, 3, 4-ish separate languages that are primary languages in the Synapse world. Because if you're working with a dedicated SQL pool, you're using T-SQL. If you're working with the serverless SQL pool, you're still using T-SQL, but it's a little bit of a dialect. If you're using Spark, Spark pool, you're writing in Python or Scala. You can also use C#, you can use R, and you can write Spark SQL. I won't even consider those languages in there. And then if you're using a Data Explorer pool, that's the Custo query language, KQL. So you have these different languages. If you build Synapse pipelines, you might be writing some JSON code. You may be integrating with notebooks. You may be integrating with, say, .NET wrapper code or something. So you've got these different languages, these different products, these things that do work together, but they don't mesh entirely. They are still separate tools or separate experiences, even when they use the same data. The fact that you can have a lake database in Azure Synapse Analytics that works with your serverless SQL pool and with Spark pools doesn't mean that this experience is completely fluid. It doesn't mean that I can write a T-SQL statement against the serverless SQL pool and expect that the behavior is exactly 100% the same as if I wrote Spark code, PySpark code, and accessed the data. There can be minor metadata differences. There can be some operations that are allowed in one but disallowed in the other. Like in serverless SQL pool world, I can't insert data, but I can insert data from the Spark world. So you do have these nuances. And this is an area where Eugene, who is brand new to the topic, hadn't worked with this before and is trying to get into it realizes, hey, this is tough because it's not one thing to learn. It's a wide variety of skills. And just because you pick up one skill doesn't mean the others will come naturally to you. And he goes on and talks about this as you have many different ways to solve this problem, but sometimes you don't necessarily know which of these ways is the best way, the correct way to do it, which means you're having to learn a lot of different methods, and you may end up being wrong. Like, oh, I picked the serverless SQL pool, but it turns out that that's really not a problem for it. It's a problem that a dedicated SQL pool will do better at, or more likely vice versa. 9 years to retirement. You know, that's going to end up like a cop movie where you'll be 3 days from retirement, and then a server rack will fall on you. It's unfortunate. We'll mourn you, Anders. Not for very long, but at least for one segment. But this is, yeah, and I mean, Eugene has always been good at metaphors. Talks about Azure butter knife. Like, if you have 8 different types of knives, including Crocodile Dundee, where this is actually a spoon. I see you've played Knifey Spoony before. You have these different types of knives for different purposes. Even when the tool looks roughly the same, its specific purpose can be different. And if you know that context, if you know what the purpose of the tool is, then you can understand why it's better or worse at specific tasks. But coming into this blind, it can be quite difficult. So Eugene came up with this post. It's really interesting. Share some thoughts. I dropped a link to it in the chat here, and I think it is worth talking about as itself, as a post in itself, and also a broader idea, kind of even touching in on Anders' joke of, well, glad I don't have to think about this because I'm going to retire before it becomes relevant. And that is that this is a world in which we see more rapid change in some aspects than we're typically used to. When you think about warehousing, warehousing has changed quite a bit over the past 20 some years, but there are still some main standards that really have remained the same. If you think the star schema, ever since Kimball's the data warehouse toolkit came out, that Kimball model has changed at the edges. You know, I'm not going to say, oh, it's been static ever since the first release of the Kimball's method. It has changed. You know, we've seen slowly changing dimensions 0, 1, 2, 3, and then it's 4, 5, and 6. So it's not just type 0, type 1, and type 2. We've seen data vault. We've seen data meshes. Data lakes have become prominent. We have seen adaptations of the Kimball approach that do more or less. And I do recommend when the podcast comes out, check it out. We were able to snag a PM for Microsoft who worked with Azure Synapse Analytics, and he was able to give a rundown of, you know, what the different products do, of the purpose of data lakes, and the theme behind the show was the data lake house. So you'll get a nice overview of where all this fits into the world and how difficult some things can be. Where I want to go with this, I suppose I may want to take this in a slightly different direction so that I don't completely stomp all over that podcast, because I think it's worth listening to. It's worth getting the guests' ideas. And I didn't say too much because I'm usually just there to troll. So when we have a good guest, I don't want to ask too many. I don't want to undermine too much. But I think it's a interesting problem to think through, and looking at just how fragmented the development world is, And it feels like it's more fragmented than it was a decade ago. And it was more fragmented then than it was 2 decades ago. That there has been increased fragmentation in terms of utilization of libraries and tools, in terms of frequency of updates, the development of new tools, the adoption and disillusion of tools. So we've seen, over the past, let's say 20 years ago, if you were let's make it 17 years ago. The year is 2006. You're using SQL Server 2005 because your company is on the cutting edge. You've got your SQL Server integration services, analysis services, reporting services, your database engine. You're using the brand new SQL Server Management Studio. You're just riding that line. And all of that is within the Microsoft world. If you fast forward 6 years, it's now 2012. SQL Server 2012 is coming out. If you're on that data world, you're still basically using SSMS. You're probably using integration services. You might be using analysis services. You probably are using reporting services, whether you want to or not. A few years after that, we still have those tools, but then there's this proliferation of Azure and AWS services around databases, around data movement, not to mention that whole wider world of the relational world. Oracle, Postgres, MySQL. In the non-relational world, the expansion of Hadoop, adoption of Spark. You have MongoDB. You have a variety of other platforms that have come out and had some extent of staying power. Not nearly as strong as relational databases, but they're certainly around. And we've seen the shifting of tools to where warehousing is less of let's use integration services to load our SQL Server from another SQL Server, and more into using something like Azure Data Factory or Synapse pipelines to load a data lake, or writing Spark jobs in Databricks to load a data lake, and then curate or cleanse and curate that data, make it available in a warehouse. And there are more options open to us with more challenges associated with those options. The challenge of cost, the challenge of balancing tools, of realizing business value in the most effective way possible, of maintenance. There are products that burned bright and then burned out. And if you were using one of those products, like if your company adopted Cloudera distribution of Hadoop or the Hortonworks data platform, and you rode hard in on it, you could switch to Cloudera's cloud offering, which is available. It's a thing. But if you're living on premises and you had dedicated tens of thousands of hours and millions of dollars into Hadoop, there's nowhere to go. You're kind of having to shift out of that and into something else. And I know that's always been a risk, but with the proliferation of additional data technologies, the likelihood of something failing is much higher than I think it was a couple decades ago. And yet, if you stuck with the same base SQL stuff, you could run the same thing today as you did in 2006. And it would probably be better than it was in 2006. So if that solved your problems, then yes, it's a solid strategy. If that wasn't sufficient to solve your problems, there are reasons to use other technologies, like the ones that you have aren't solving the problems that you need to solve, with maybe data utilization in terms of sheer amount of data, or the types of queries you need to run, or the latency at which you need results, the skill sets of your developers. there are a few reasons why you might use something else instead. But following on your point, Anders, I do want to drop in a link to our next topic of the night. So this one I gratuitously stole from Brent Ozar's newsletter, and it is entitled "Big Data is Dead." So the premise behind this article is Jordan Tigani, hopefully I'm getting that name right, was an evangelist at Google working on the BigQuery engine. And he was an engineer, enjoyed public speaking, and so he went out there and told people about the joys of BigQuery. And then throughout this entire thing, he now works for a database platform company called DuckDB, which is this mother duck. And the gist of this is, historically, people were selling this idea that data will grow logarithmically, and eventually over time you simply will not be able to work with the data that you're going to have. You'll have just too much and all your systems will explode and it'll be awful. Unless you switch to using our product, which can help you scale out and grow logarithmically at the cost of your cloud bill growing logarithmically as well, or exponentially as well, excuse me. So this was the impetus. And I've seen slides like this from a bunch of different companies at a bunch of different times. The number that gets thrown out is zettabytes or yottabytes or whatever indescribably large number that humans can't even think about except in abstract terms per period of time. So this is what drove a lot of sales. Now, scrolling down a little bit, basically, Jordan makes the point that for most companies and most times and situations, that first chart of exponential growth doesn't really describe their situation for a few reasons. And one of them is that data quantity radically differs by company. There are some fairly large companies that don't have enormous amounts of data, and for a lot of organizations, you might have dozens of gigabytes of data total. Meanwhile, if I tell you Azure Synapse Analytics, the dedicated SQL pool, the expectation going in is that you have 1 terabyte of data and that you're talking about roughly 1 billion rows or so in your largest fact table. That's when the dedicated SQL pool starts to really be worthwhile. You can have a smaller amount of data and still get benefit from the dedicated SQL pool, but usually you don't reach that cost benefit threshold until you reach that point. So for a large majority of the companies like Jordan is mentioning here, they don't have that much data to put into a warehouse to begin with. And this is a normal thing. Most of us don't have unlimited clients, even if we have 100% market share. Sure. So you have essentially a growth function of data, but even when you have that growth function of data, which may be linear, you have a certain number of customers performing a certain number of actions, a certain number of times per period, and each action is approximately this size. So maybe you have thousands of customers, each of which generate about 1 megabyte of data per month. So if you have 1,000 customers, 1 mega data per month, roughly 1 gig per month. And you could do the math and add it up and say, oh, well, eventually we'll reach 1 terabyte. I mean, it's going to take 1,000 months. So, quite a while. But hey, eventually we'll get there. Well, on top of that, there are some other concerns, some things that typically we don't access all of that data all of the time in every query. That would be dumb. In fact, I have an entire talk on the idea of using the serverless SQL pool in Azure Synapse Analytics. And one of the main points that I bring up in this talk is, if I jump ahead to one of the late slides, whoops, I grabbed the wrong one. There we go. So on this topic, if I jump to one of the latest slides, basically we spend a lot of time trying to work out how do we save money, and part of this is that scan the minimum amount of data necessary. So we're already saying, look, don't scan all of this data. Don't try to access it every time. Only access what you need when you need it. Many terabytes is not hard to deal with in SQL Server anymore. Yeah, or normal SQL, which naturally my brain translated to SQL Server, but it could also be Oracle, Postgres, MySQL. Yeah, absolutely. Actually, there's a point in this article as well that gets to that. But we have this immediate recommendation of, oh, you have a lot of data, but write queries that get the least amount of it. I mean, that's not new. This is query writing 101. So you have a query. How do I write a query in a way that performs quickest? Well, start with the lowest amount of data I can possibly get to, or that I possibly need, and that's going to get you a long way. So if I access, the table that has 1 billion rows or the table that has 3 rows, and I need to filter on those 3 rows, well, it's better for me to get the 3 rows first than to scan the 1 billion rows and then filter them out later. That's as generally solid advice. Or that I want to use indexes that are the most restrictive in their filters, so that I throw away the most potential data before actually taking that cost of accessing it from disk or accessing it from memory. Make the devs write the queries, DBA optimizes it, becomes a hero. Yes, until you find out that there are more devs than DBAs, and that some of those bad queries start getting in, and you have a snowball effect, otherwise known as most development environments. All right. So understanding why large data sizes are rare. Think about where the data comes from. As mentioned, you don't really have avenues for enormous amounts of growth to begin with. Most companies don't generate that much data. And also, even if you do generate a lot of data, storage and compute are separated. Now, this is, I think, one of the biggest long-term benefits that we've gotten from the Hadoop mantra, that Hadoop concept. And that is, storage and compute don't have to be the same thing. They don't have to scale linearly. They don't have to scale consistently. You can require more storage while needing less compute on it, and vice versa. We're seeing in cloud environments that there is a strong impetus toward choosing your compute and your storage separately, working with them separately, and that you can modify one without having to modify the other. So I may have my Data Lake Storage Gen 2 on premium tier storage, so it's very fast, but then if I have maybe not frequent access of that data, I may only need a small amount of compute. My Spark cluster might be very small. It may be just 2 nodes or 3 nodes. Versus in cases where I need much more compute power, maybe I bump that up to 7 to 9 nodes. So the storage remains the same. The compute adjusts up and down based off of what my actual needs are. Another thing mentioned here is that workload sizes, they are smaller than overall data sizes. Going back to my discussion of filters, this is something we've worked with in relational databases for decades. The concept isn't new or unique to data lake or extended storage systems. You want to get the data that you need at the time you need it. And so a couple years ago, he did an analysis of BigQuery queries looking at customers spending more than $1,000 a year. 90% of those queries processed less than 100 megabytes of data, which is one of the first things that we recommend when how do I make my queries more efficient? Or in this case here, how do I save money? Scan the minimum amount of data, use the right file formats, get smaller result sets, perform filtering, pre-calculate aggregates. So doing some of these things that basically result in reading less data, writing less data, and filtering so that we can read faster and less. So this is not a thing that is unique to BigQuery. And wow, I've been doing those forever. Yeah. I mean, I get it. I get it, Anders. This is not, oh my gosh, wow, so new, so radical. This is instead saying, hey, when people were pushing services like BigQuery, like even dedicated SQL pools, Redshift, that there are customers who get good value out of these products, but that you don't need them for everything, that not all companies need them, and that pushing people toward it was a net negative. It is radical for people who do not understand relational database design. I mean, this I think does tie in with the notion a bit because, oh, well, at my company, my relational database is really slow, and thus I need to use MongoDB because MongoDB is faster. I mean, at that time, it lost your data, so it got even faster as a result of that. But yeah, if you have people who know what they're doing, who can design relational databases in a way that they're supposed to work, then you get really good performance. And this is something that actually tying back in with Eugene's discussion point. Yeah, it goes for pretty much all tech. Yeah. Going back with MongoDB is web scale. Yes. And I want an iPhone 4. Going back to the Eugene discussion, something that won't make the recording for SQL Data Partners. We talked a little bit afterwards about the adoption of Spark and how it was kind of interesting that Spark just kind of took over from Hadoop. And a big part of it was that people realized, my opinion on this, people realized two things. Thing number one, most of my queries, most of the data I'm accessing isn't petabytes. It's hundreds of gigabytes, dozens of gigabytes, maybe a terabyte. But thing number two, at the time Hadoop really started taking over, you were talking about 8 gigs of RAM on a server, 16 gigs of RAM on a server. At that time, AWS EC2 had 2 gigs of RAM on a VM. You got 2 gigs of RAM, and that was it. Well, you can't do a whole lot of data processing with that, especially if you're talking about, I want to process a terabyte of data and you have 2 gigs of RAM available to you. There's a little bit of a mismatch, and thus mechanisms existed to distribute that data out, spread it out across multiple machines, and have those machines work with disk a lot because that was necessary to solve the problems. Well, fast forward to today, where a server with 2 terabytes is easy. You can get 24 terabytes in a server. You can get a lot more RAM, a lot more compute power. And so the problem that previously made sense to distribute out to multiple nodes, now I have one machine that can do all of this work. And if I have 12 terabytes of RAM on my server and I have 8 terabytes of data, essentially, I don't need to distribute this out. I don't need multiple nodes. I have one machine that, as long as I have sufficient compute resources and the data is, the architecture is sufficient to solve the needs of users, if it's not completely borked, then I'm in pretty good shape. I can handle all of this on one machine running SQL Server 2019 or 2022 or whatever, that I don't need a lot of infrastructure and a Hadoop cluster and these other things. So there is a major story that you can tell about how hardware growth has made it such that some of the concepts that we were talking about here became obsolete. They were important in their time. The distributed file system that Google came up with, GFS, later became HDFS, was very important. Its legacy still lives on today, even if very few people actually use HDFS. The concepts of MapReduce, I mean, they still do live on today in Spark, even if very few people actively write map and reduce operations. You know, we're all using data frames, so not having to directly write those maps and reduces. The concepts of distributed data architecture were important at a time when I'm Google and I have a petabyte of data that I'm supposed to be running on off-the-shelf boxes, like 16 gigs of RAM, and somehow I need to be able to process this petabyte of data. In those scenarios, a distributed system makes a whole lot of sense. But scale this thing up to now I've got 24 terabytes, and then scale back the amount of data required to less than 24 terabytes, and then suddenly one machine fits it in RAM. Or even if I still have a petabyte, you know, at 24 terabytes of RAM per server, yeah, if I get 20 servers, that's half a petabyte of RAM for those 20 servers, and they can process the problem fairly efficiently. Even if it is 1 petabyte, you know, there is still some reading from disk, but not very much. So, you know, we have this enormous growth in hardware capabilities. And even when you do have an enormous amount of data, it turns out that most of the time people don't access that much data. So increase in hardware means that many can go back to keeping things simple. Yeah, I think that's a reasonable thing to say. There are organizations where there is a benefit to this, but many organizations don't see much direct benefit. I think there is still benefit to a thing like Azure Synapse Analytics and modern data warehousing. That benefit is less, I will get faster performance, and it is more integration with a lot of systems and having some of the mechanical improvements of data lakes versus having one relational database system. Even in that case, you know, your relational database is still going to be faster. It's going to be faster than a serverless SQL pool. You can see demos of, oh, well, here's 5 petabytes of data being scanned in a dedicated SQL pool, and that query alone probably cost a couple $1,000s. Well, nobody's going to, very few people are going to need to go to that level. If you need to go to that level, the tools exist. And you're probably paying enough to make the tools continue to exist. Fast enough is fast enough. I mean, that's also an argument in favor of the serverless SQL pool, that as long as your reports finish before people complain about them, they're good enough. But as far as querying goes, yeah, most of the time people query fairly small amounts of data, even when you have a large total amount, because you're looking at today's data, yesterday's data, or last week's data. Rarely are you looking at 7 years worth of data in its totality. And that comes into this little curve here, where by far the most most used data is that most recent stuff. What is happening in the immediate past? And then as you get past a day or so, things drop off, that curve drops. There's a little bump to indicate your weekly job. So after 7 days, you'll see this data accessed again. And then it drops off, and you'll have like a monthly or a quarterly or a yearly. And you'll see little bumps. But so it's not strictly a logarithmic drop. It is, however, or asymptotic drop, I should say. I keep wanting to throw the word logarithmic in. I don't know, today's a logarithmic day, but asymptotic drop with the occasional discontinuity in terms of nice little bumps here. What this means is that most of the time, most of that data, we don't use it. It's not that we don't care about it at all. It's that if we're able to process that daily data very quickly, that's going to solve the large majority of problems. If we pre-process data at higher grains, at the reporting levels, they make life a lot easier. Isn't this also fairly typical for most new tech? Quick adoption, then a return to common sense as things mature. Yeah, and as much as I am loath to even say this out loud because of how much I innately despise the man, Hegel's concept of thesis, antithesis, and synthesis kind of comes into play here. Where you have this, I mean, you can see it as the adoption of the new technology, the change in circumstances to make that technology irrelevant, and then the combination of what has been valuable in the past and what survives the challenge, essentially. So looking at Hadoop as a direct example and getting out of stupid Hegel metaphors, you have, for example, that concept of the distributed file system, which lives on today as data lakes. Azure Blob Storage, Amazon S3, both of those directly come out of the Hadoop distributed file system. They are both distributed storage technologies that separated compute from storage. Well, that concept still lives on even if companies aren't adopting Hadoop anymore. So there is this sort of synthesis of what is the best of the techniques and technologies that have come through here, or what are the things that maybe have survived. Maybe it's not the best, but it has found itself to be useful enough to find adoption in other circumstances and scenarios. This is also what I was talking about with spending even terabytes, 24 terabytes of RAM, 445 CPU cores. Basically, how much workload could you get on a single machine? And back in 2006, the answer was not a whole lot. If you have 8 gigs of RAM, if you're looking at AWS, 1 core, 2 gigs of RAM. So you get a certain amount of workload you can get for one AWS machine. Your average SQL Server at that time, you're probably running 2 cores, 8 gigs of RAM. Maybe you've got 12 gigs of RAM. 2006, I was running 4x3 for less than a terabyte of data. Yeah, I mean, now, of that terabyte of data, the question is how much of it was actively used and what were the throughput and timing requirements. 4 gigs of RAM. Yeah, 4 gigs of RAM, 8 gigs, maybe 12 gigs if you were flashy. That was about what companies were pushing at the time. And so there were specific workloads that you could do. Some workloads you were going to struggle with. Some workloads you were going to be able to take it like a champ. But if you regularly had to process, was less than 200 gigs after I finished archiving. Right. But if you regularly had to process a terabyte of data and people were constantly hitting it, and they were randomly accessing the entire terabyte of data, not just give me the last page or the last day. 4 gigs of RAM wasn't going to cut it. You would have much slower, especially we're talking pre-SSD. So yeah, I would have melted that server. Exactly. But we defined the workloads. We worked within the constraints that we had and found out that, yeah, most of the time people just access certain paths of data, certain patches of data at certain times. For reporting, this is why aggregation works so well. That, okay, well, here's your current day data, and then let me give you aggregates for the past 7 days. That data doesn't change very frequently, so I can, it's past data. It doesn't update that often, so we can show it to you and maybe update it once a night just to capture any changes that have occurred since then. And we developed patterns to deal with the hardware constraints that were available at the time. Those patterns still exist. They still make sense. They make sense in Synapse, in Redshift. They make sense on premises in SQL Server. I think that as a general principle, it makes sense overall. And with this growth in hardware capabilities, this is a big part of why we're seeing that relational databases, let me pull up DB engines, relational databases make up a pretty substantial amount of the marketplace and have forever and will for a very long time. If I go to the list here, we look at the top 10 databases here on this list. Relational, 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 not relational, cache. So object, document model, cache model, relational, search engine style, relational, relational. You're talking 7 of the top 10 here. And then scroll down just a little bit, and after Cassandra, you've got relational modern warehousing, relational MySQL breakoff, and then you get a little bit more. But there's a lot of relational database technologies in this list, especially in that top 10. And you're not seeing Mongo go and take over SQL Server. There's a little bit of adoption of other technologies around SQL Server. I think that this probably undersells the Microsoft space a little bit, because you have Azure SQL DB down here, and then there's also Synapse down here. And I think that those two bleed away some from what would be SQL Server as a whole. So as far as it goes, we have this list, and this list has not changed very much. You will occasionally see something move up or down the list, but 8 of the top 10 have been the same for a year. And then 9 and 10 just switch places. And there's a chance that maybe Cassandra moves into the top 10. I'm not sure about that. There's a chance Snowflake moves into the top 10, possibly. But looking at the trend chart over a longer period of time, you have at that top, these are relational databases. That's a relational database. Mongo's the only non-relational database that's in that same atmosphere when you look at it logarithmically. Hey, proper use of logarithm this time. So short version of this, as hardware has expanded, I think it breathed a good amount of life into relational databases as a technology. I think it allowed those of us who focus on relational databases to really remain in that space without having to go and learn Hadoop technologies, Spark technologies, stuff that I put together several talks on over the course of my doing things. So yeah, I've been pushing Spark and Hadoop for years. I don't regret it at all. I think that it's been a very useful, it's a very useful thing to know about, to learn, even if you still focus in the relational world, even if most of the technological work that you do is in that SQL Server space or the Postgres space, and that you stay on premises. I think there's still some value in understanding what are the other paradigms that are available, and possibly adopting some of the concepts, even if you don't take the technologies or the outcomes. Now, I will put a little bit of cold water in this section where data is a liability. There are parts of this that I understand and agree with. So, for example, if you have to deal with regulatory regimes, that you do have to track data and get rid of some of it after a certain amount of time. But I would say data is a liability, yes, technically, but data is also an asset. And one of the biggest pain points that I have run into running a predictive analytics team, being in that space, is an organizational desire to throw away data. And I've seen this at a lot of companies. And this is a common complaint among people in the data science world, that, yeah, you want me to predict what customer behavior would be like based on certain scenarios, but you don't have any historical data on that scenario because you overwrite it. So let me give you an easy example, and that is customer churn. So I want to figure out which of my customers are most likely to leave. Maybe they don't renew their contracts, and try to get some idea of how we can entice them to stay. Well, if I throw away all of my data from every customer who has churned, I have no information about what their situations were like, or I have limited information about what their situations were like. And if I wanted to know what did it look like 6 months before they churned, like if you have an annual contract, you're probably thinking about this thing 3 months from now. You're probably thinking about this like 3 months before the contract expires, or 4 months before. So what was the situation like at that point? Oh, I don't know, because we don't keep that data. And this is a common pain. Like if there's not a program manager, a product manager, or a development team, or somebody who actively needs that data, then there is a tendency to get rid of it. That's why you have backups. Yes, if you have, restore 300 days worth of backups one at a time, just to collect that data. This is actually, I think, one of the biggest benefits of a data lake, is that I can have my source systems remain fairly tight. I can collect that historical data for data scientists. I can process it separately in separate paths, and that cost of storage is very cheap. So even if I'm generating 1 gigabyte per day, which is a lot, or even if it's just 50 megabytes per day, if I'm not generating an enormous amount of data, it'll be, it's, how do I want to phrase this? If I'm not generating an enormous amount of data per day, it doesn't cost too much to separate it out in different ways. Where, okay, for the application, you just need to see the latest version. For research purposes, we need to see all those prior versions. And in that case, oh, well, now my data costs have gone from $5 to $12. Not a huge difference. Now, if we're talking about hundreds of terabytes or petabytes, yeah, there's a difference there. But one of the problems of research and analysis is we don't always know what information we want before research begins. And as a result, well, we may be wrong. It may turn out that, oops, I really do need all this data, and I didn't know that I needed it at the time, and we deleted it, and now we can't go back and get it again. especially if it's constant deleting over time, if it's overwriting, type 1 slowly changing dimensions, or overwriting existing records. So, moral of the story, I do believe that a lot of this article makes sense, is correct on the whole. It does help explain why we have seen this decline in utilization of Hadoop and even some decline in Spark, although Spark is still a very popular engine. So seemed like two good topics to talk about tonight, and that got us to 7 p.m. Eastern Time, which is about the time when we can drop off. Thanks everyone for coming in today. Appreciate you here. And remember, tomorrow we will have at meetup.com/TriPass. You can already see the schedule, but we're going to have talk about Query Store. So Pablo Lozano, soon to be former coworker of mine, he's sticking around. I'm not. Will be talking to us about Query Store. He'll be coming at us from Spain, so it'll be very late his time. But talking about some of the really cool things you can do with Query Store and an open source library that will make Query Store so much better. And then our main meeting and our BI and data science. So main meeting, Peter Shore, talk to us about weight stats. And Paul Turley will give us a primer on Power BI when you've got a whole lot of data. Maybe it's not big data, but it is a lot of data. So with this, I'm going to wrap things up now. Thank you so much, everybody. And until we see each other again, take care.